Okay. So here we are going to talk about the contact process, which is about making sulfuric acid. What is the formula of sulfuric acid? Sulfuric acid is H2SO4. Now here, first of all, we need to see why do we call it the contact process, because this process of making sulfuric acid, it was actually discovered by the German scientist whose name was Contact. And that is why this industrial process is actually called the contact process. Now, let's go ahead. Okay, what are we going to do is the raw material. So now let me put up here the raw materials that we would be needing for that. So the raw materials, quickly we go through what we will need. We will need sulfur, and sulfur, where we will be getting it from? We will be getting it from beneath the ground. Okay, then what we will be taking? We will be taking it from sulfide ores. There are different resources to get the sulfur from, and we will be getting it from petroleum or natural gas. Okay, from petroleum. So basically hydrogen sulfide. We make it clear. Hydrogen sulfide from where? From petroleum or natural gas. Now let's go through the process, how these raw materials will be used in this process. So here, when I am writing, okay, the contact process, the first step that I am going to take is, let me write here the whole process. Let me put up here. So here, process, the contact process, which is the very important industrial process for making sulfuric acid. So in it, we are going to take sulfur first. Yes, sulfur is the first raw material that I am going to use with that. So sulfur, what will happen? It will be burned in air. It will be roasted in air. Yeah, these are the good keywords to mention for that. Burn or roast in air. This is the first step. So when this air, it is burnt or roasted in air, what will happen? It is going to give us the equation sulfur S plus O2, which is going to give us SO2, which is sulfur dioxide. Okay, so sulfur, which is solid. This is always a good practice to put the state symbols. Sulfur dioxide is also the solid. So this is one. Okay. Now next, what will happen? This sulfur dioxide, it needs to be burned with more oxygen. So what are we going to do? We are going to mix more air. Mix more air here. Okay, so mix more air. Also here we are going to put up our conditions. What are those conditions? We are going to pass over 4 separate beds of what? 4 separate beds of catalyst. Okay, beds of catalyst. And what is our catalyst? Catalyst is vanadium 5 oxide. Let me write these conditions here, so will be better for us. I use different colors. So reaction conditions that I am going to use for that, as I mentioned, this catalyst, which is actually vanadium. We are going to write like this: vanadium in bracket 5, vanadium 5 oxide. Okay, and if we have to write the formula, we will mention how. We will mention V2O5. V2O5. This is my catalyst for that. Now I go to other reaction conditions. Pressure that I am going to use 1 till 10 atm maximum. Other than that, temperature that I am going to use is the compromised temperature, which is about 450 degrees Celsius. That actually we call what? Compromised temperature. Okay, this is what we have. Now, getting back to our stages there we were talking about, so reaction conditions we already have. Now here we are already passing it over to the catalyst vanadium 5 oxide, and what will happen here? It is gonna make, since sulfur dioxide was already there and we were adding more oxygen into it, and it is going to give us what? Okay, this is the main equation of the reaction. Since it is reversible reaction, so we will be using this equilibrium sign. And let's balance it. How I am going to balance this equation? Yes, sulfur dioxide, which is a gas, oxygen is a gas too, and sulfur trioxide is a gas. Now here, yeah, this is the main equation of the reaction that we are going to keep in mind. Keeping in mind that forward reaction here is what? It is exo, backward is endo. Later, when we do equilibrium questions, it will help us to know. Now, since sulfur trioxide has already been made, now what is the next step? Because ultimately what we have to go for what? For making sulfuric acid. Now, what are we going to do? Because the reaction is exothermic. Okay, and reaction is exothermic, so we are keeping the temperature quite compromised, quite low. Okay, why? So we can save the cost as well. Now, this sulfur dioxide, it is going to be absorbed into a 98% solution of sulfuric acid. Okay, what will happen here? I am going to dissolve it in. So here, what will I write? Dissolve in concentrated sulfuric acid. Concentrated, I use the same color, right? Concentrated sulfuric acid. And when we dissolve in concentrated sulfuric acid, do you guys know which product is going to be made? It is actually going to form oleum. What is that? Let me write here SO3. It will be dissolved with sulfuric acid, H2SO4, and it is going to give us H2S2O7, which is actually what? Which is oleum. Okay, so sulfur trioxide is a gas, sulfuric acid, it is liquid, and oleum is a liquid. This is what? This is basically oleum. Oleum formula we need to remember. So yeah, we are going to write, I write here. So if you guys can remember, oleum, yes, capital letters, right? Okay, so now since this oleum has been formed, now what will happen? This oleum is mixed with little water. This is the last step in this process. So this oleum, it will be mixed with, here I write, yes, oleum is mixed with little water. So when this oleum is mixed with little water, what will we get? We will actually get concentrated sulfuric acid. What will be the equation? Oleum, which is H2S2O7, okay, which is liquid. It will be mixed with water, H2O, which is also liquid, and it is going to give us what? It is going to give me H2SO4, concentrated sulfuric acid, which is liquid, to balance the equation. And this is how I will be able to obtain this sulfuric acid by this contact process. some of this 98% acid is returned to the absorber, and the rest is run off to be used as concentrated sulfuric acid.